Classical Mechanics, a detailed study of mechanics and dynamics, written by Mark Hedges, narrated by Aria Montgomery. Chapter 1, Introduction to Classical Mechanics. Classical mechanics is the foundation of physics, describing the motion of objects under the influence of forces. It is based on Newtonian principles and provides the groundwork for various fields such as engineering, astronomy, and applied sciences. This chapter introduces the fundamental concepts, historical context, and different approaches to classical mechanics. Classical mechanics originated with the pioneering work of Galileo Galilei and Sir Isaac Newton. Galileo's studies of motion laid the foundation for Newton's laws, which were later formalized in Philosophiæ Naturalis Principia Mathematica, 1687. These laws revolutionized the understanding of motion and force, enabling precise predictions of mechanical systems. Before Newton, the Aristotelian view dominated, which incorrectly stated that objects require a continuous force to remain in motion. Newton's insights replaced this with the concept of inertia, fundamentally changing physics. At its core, classical mechanics describes the relationship between forces, motion, and energy. It assumes that time and space are absolute and independent entities. Unlike quantum mechanics and relativity, which describe extreme conditions, classical mechanics applies to everyday objects moving at speeds much lower than the speed of light. The field is traditionally divided into several branches, including kinematics, which studies motion without considering forces, and dynamics, which examines forces and their effects. Two major formulations of classical mechanics exist: Newtonian mechanics and analytical mechanics. Newtonian mechanics focuses on forces and their direct influence on motion using Newton's three laws. In contrast, analytical mechanics, encompassing Lagrangian and Hamiltonian mechanics, uses energy principles to describe motion. While Newtonian mechanics is more intuitive and widely used in engineering applications, analytical mechanics is often preferred in theoretical physics and advanced problem solving due to its efficiency in handling constraints and complex systems. Classical mechanics is crucial in understanding celestial mechanics, vehicle dynamics, structural engineering, and fluid dynamics. It is used in space exploration to calculate planetary orbits and spacecraft trajectories. Engineering disciplines rely on it for designing bridges, buildings, and mechanical systems.
Sample complete. Ready to continue?